Hey there, everybody. Welcome back. We're getting ready to start 5.3 in John Blakely's textbook. If you have not met Mr. Blakely, he is another teacher here at COS. He was actually my teacher when I was a student here. I'm a former student of COS, and I got my degree in mathematics, came back here. He was my instructor for pre-calculus. Let's go ahead and take a look at what we got. No, trigonometry, I think. We're going to take a look at what we got here. We're doing 5.3. This is on adding and subtracting rational expressions. And we'll make two videos. In part A, we will do common where they have a common denominator. And in part B, we will do where they do not. They have a common denominator already. So that's what we're going to start with first. Remember, this was just like fractions. If we had 2 over 5 plus 1 over 5, we can treat this as 2 plus 1 over 5, which is 3 over 5. And the same thing as with subtraction. This principle works, same idea, with rational expressions. If I have P over R plus or minus Q over R, I get P plus or minus Q over R. And the big tip I'm going to give you for all of this, and it happened when we were doing just adding and subtracting expressions. And double check your stuff if you're subtracting. Double check you distributed on subtraction. That's Hefe's pro tip. Pro tip by Hefe. Oh, you guys don't get the Hefe experience. Maybe in another video, I'll tell you guys. I might have it in my orientation. Let's see. Let's look at some examples here. Let's start with something simple. 2 over y plus 3 over y. We put those together. We can add the numerators. And we get 5 over y. Again, y cannot equal 0. Next example, we'll kick it up. No, I'll not kick it up. Not really. We'll just have a variable in one of the numerators here. We put them together, we get x minus 2 over x minus 5. And next one, we have a over a squared minus 6a plus 8 minus 4 over a squared minus 6a plus 8. If I put this together, I have a minus 4 on top, a squared minus 6a plus 8 on bottom. If you have something that's bigger than squares, check for cancellations once you put together. So the bottom here factors. This is minus 4 and minus 2. So after I cancel, I get 1 over a minus 2. But a minus 4 cannot equal 0, and a minus 0. These two will cancel. Okay, now let's make it a little bit bigger, more fun. We've got x squared minus 4x minus 1 over x squared minus 2x minus 8 plus 4x minus 15 over x squared minus 2x minus 8. When we add these together, we can add just fine normally. I'm going to put the x's next to each other and the constants next to each other. And when we combine those like terms, we have x squared minus 16. The minus 4x and plus 4x cancel. We will factor. This is a difference of squares. This is x minus 4, x plus 2. So the x minus 4s will cancel, but not before they leave behind it as a domain violation. And we're just left with x plus 4 over x plus 2. We also have x plus 2 as a domain violation. All right. Let's give you another one. I want you to start trying to do these on your own. Pause the video. That way you can try to do it and then you can check your work against mine. If you're waiting to do it till you do the homework just tells you the answers and you can't see the process. Learn by practicing during a video. Here we've got minus here. So both denominators are x squared minus 14x minus 72. The numerator on the left is x squared minus 2x minus 35. We're subtracting. The second numerator is 4x plus 5, that should say. All right, if you put them together, you should have the same denominator. And I am just going to put all the top together and distribute that minus first. When I combine like terms, squared minus 6x minus 40. On bottom, I get x squared minus 10x minus, or 14x minus 72. Now this top one, I can recognize what it is. That's x minus 10x plus 4. Let's see, multiplies the negative 72 and adds the negative 14. 1 and negative 72, no. 2 and negative 36, no. 3 goes in 21 times, that's not it. 4 goes in 18 times, there we go. Or negative 18, add to negative 14. This ends up being x plus 4, x minus 18. My violations are x plus 4 equals 0 and x minus 18 equals 0. So x cannot equal negative 4 or 18. We will cancel like terms. X plus 4 appears on top and bottom. And we're left with x minus 10 over x minus 18. Remember, there's subtraction between these. I can't cancel out x's, even though I see an x on top and bottom. They are not multiplied by everything on top or on bottom, so I can't cancel x's. Okay? So that'll be the simplified form there. And just because you like to be tortured, if you didn't, you wouldn't be taking this math class with Mr. Jones, Professor Hefe. We're going to go x squared minus 2xy minus 17y squared over x squared minus 14xy minus 51y squared. And we're going to subtract 2xy plus 4y squared, and we'll have the same denominator. Go ahead and try to work that out. Okay, I'm going to mark this right here. That's a negative and that's a negative. So that when I put them together, the negative 2xy here and that negative 2xy here add together to make negative 4xy. I guess I didn't need such a big fraction. And negative 17y squared minus 4y squared is minus 21y squared. Bottom is still this. If I factor the top, I have x minus 7y and x plus 3y. Here, let's see, 51, 3 and 17. X plus 3y, x minus 17y. So I can cancel out the x plus 3y's. And I'm left with x minus 7y over x minus 17y. If you've forgotten how to factor when there's x's and y's in it, go back and look at the factoring videos. We did them in chapter 3, chapter 4. They were probably in 4.4. Maybe 4.5. That will be it for the common denominator video. Peace.